According to the physical properties of alkenes, so we are focused on the three parts. The first part we discuss about physical state, second boiling point, and the third is solubility. So according to the physical state, basically, if your organic compound consists carbon 1 until carbon 4, so the phases of them are gases. And then we have the carbon 5 until carbon 17. Carbon 5 to carbon 17, the phases is a liquid. And the upper than that, this is the waxy of solid. So, if we discuss about the concept of the boiling point of alkane, we must to focus into the concept of intermolecular forces. So, basically, inside the alkene, no functional group presence. They basically consist of the carbon and hydrogen only to achieve type. So, therefore, electronegativity of them are almost same. So, these alkene are non-polar molecule. If they are non-polar molecules, means the intermolecular forces must be van der Waals forces. But according to previous lesson, van der Waals forces consist two parts, either London forces or dipole-dipole forces. So all the alkenes here are non-polar. So the specific forces is a London, but inside the explanation we just focus on the terms of van der Waals forces exist between their molecule. So the factor affecting the strength of the van der Waals forces, which is the molecular weight, which is the number of the carbon atom is directly proportional to the strength of forces. So if we have the higher number of carbon atom, so we have the highest of molecular weight. So the strength of a van der Waals forces is the stronger. So more energy required and the boiling point of the compound are highest. So, if we compare to the homolog series of the alkene, carbon 1 until carbon 4, basically the strength of the forces are increases and the boiling point also increases. But the next factor, if we have a branch alkene, so if the branch alkene, the strength of the forces become lower and the boiling point of them, the lowest of the branches become the lowest of the boiling point. If we arrange them, branch alkene lower than linear alkene, which is we can call as a straight chain, and the lowest of the cycloalkene because we have the symmetrical compound. But according to the branch alkenes, the factor affected of them are surface area, molecular surface area. So we can call, if we have the higher number of branch in molecule, okay, the surface area of the molecule become decreases. So kenapa? What happened? The van der Waals forces between molecule decreases, energy required decreases, and the boiling point also decreases too. So if we compare to the example, open change. Your first step, calculate the total number of the carbon atom. This is your 5 carbon. This is also 5 carbon and the third also 5 carbon. Differences of here is the branch. This is 1 substituent and this is a 2 substituent. Means this compound have the more branch. If the more branch, consider kesannya adalah bila more branch, surface area lower and van der Waals forces also lower. So this branch, the analogy we can refer to as a ball. So the contact area of a two ball only at this part. So this is a lower contact area, lower van der Waals forces, less energy required to overcome the forces between molecule and the boiling point become lower. How about the cycloalkane? If the cycloalkane, for example, I have the cyclohexane. So, this we can classify as the higher of the boiling point. So the character of the cycloalkane, the structure molecule become the planar, and there is the symmetrical molecule. So the surface area is the higher, so van der Waals forces become stronger. So boiling point is the higher according to the higher of the energy required to overcome the forces. So as a conclusion, the factors of the boiling point, you must be refer to the molecular size of the compound and the branches of the compound. Now we try to the example 1, page 17. Okay. So basically, what happened? We must calculate the number of carbon atoms. So our step, find out number of carbon. Next, check molecular size. Next, check surface area. Check the strength of the energy. And finally, check the boiling point. Okay, so what happened? We have the one carbon atom, the first molecule, second carbon, and then for the third molecule, we have the three carbon atom, and the fourth molecule, four carbon atom. So the factor affected of them are number of carbon atom. How we explain? So the first thing, you arrange them according to the increases order of the boiling point, and you can set or you can label your writing. So for example, I label this is molecule A, molecule B, molecule C, and molecule D. And I can write down, okay, factor pertama, number of carbon atom. And also that is proportional to the molecular size. So we can start the molecular size increases in order of what? Arrange them. CH4, C2H6, C3H8, find next C4H10. Next, after factor molecular size, you must be state the factor of surface area. So, kita boleh state that the surface area increases in order of, arrange them again, CH4, C2H6, C3H8, C4H10. Next, after you discuss about the concept molecular size, you must be discuss the surface area finalized relationship in the boiling point is energy. So we can start hence the energy increases in energy required. Energy required to overcome the forces between molecule increases in order of, arrange them again, CH4, C2H6, C3H8, and finalize C4H10. And for the lastly, we can make conclusion, hence C4H10 is highest boiling point. So remember, we can arrange themselves according to our explanation, but it must be considered the similar factor. Our factor for this question is the increases of the molecular size. Means we can make conclusion, molecular size of the molecule is directly proportional to the strength of the van der Waals forces and directly proportional to the boiling point. Okay, now we are focused for next example. We must be identify what is the factor involved of this compound. So what happened for this structure? I suggest We redraw again to find out the specific compound. So this is, I try to expand it in form of a condensed structure. So we have the CH2 three times. Next, the second structure. Sorry. Okay, and for the last structure, structure number 3. So this is a bracket. So I try to expand it to identify the specific situation for the structure given. So CH3 two time means we have a branch of the structure. Okay. After you would redraw the structure in form the specific the structure, and you must be find out the next step the number of carbon atom. Compare it first. So the A compound consists of the 1, 2, 3, 4, 5 carbon atom, and the B compound consists of also 5 carbon atom, and the C compound also consists the 5 carbon atom. What is the differences of them? So the factors of here are concept of branches. So we can label for this structure according to the ascending order of the boiling point. So we can conclude that the more the branches, the lowest of the boiling point. So we can conclude the B is the lowest boiling point. So we can rearrange the structure B, lowest boiling followed by C followed by A. So what happened? Factor kita adalah branch. So explanation number 1 here, you can state all molecules have same number or same molecular size factor. Same molecular size but different in number of branch. So we can start the number of branch is increases in order of A, C, B. So next means B has lowest surface area, thus weaker van der Waal forces, therefore less energy required to overcome the forces between B molecules. B is lowest boiling point. So, according to the previous example, remember, inside your explanation, you must be state these forces exist. If no forces exist inside your writing, so means your writing is incorrect. So, as your task for boiling point, so you must be complete the task, example and also the exercises question from the page 71 until 72. All of them are concept of boiling. Okay, so the second part for the physical properties of alkanes, we can call as a solubility. So, if the concept of solubility, you must be identify who is your solute and who is our solvent. So for right now, we learn according to the hydrocarbon mean our solute is alkene. And our solvent consists too, which is what? Polar solvent. And for the second part, non-polar solvent. Okay, so that we can classify who is our alkene. Alkene is a non-polar molecule. So if a non-polar molecule, you want to soluble the alkane or cycloalkane, it must be soluble in similar types of the compound, which is must be soluble in a non-polar solvent. So what happened? We can conclude that all alkane unable to form hydrogen bond with a water molecule, because water molecule here is we can conclude as a polar solvent. So we can state that alkane can soluble in non-polar as a benzene, carbon tetrachloride or CCl4 solution, chloroform and other hydrocarbon.